Salam alaikum, bonjour à tous. Bienvenue à cette deuxième édition du webinaire technique de l'événement le challenge web AI pour cette année. On est très 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 heureux de vous avoir aujourd'hui. Donc, mon nom est Sofiane, je suis ingénieur senior chez IBM et je vais avoir la chance aujourd'hui d'être l'animateur de ce webinaire. Encore une fois, aujourd'hui, on est très heureux d'avoir des invités de qualité avec un sujet super intéressant et on souhaite que vous soyez tout aussi intéressés. Donc aujourd'hui avec moi, j'ai la chance de voir Yasmine pour une deuxième séance. Donc bonjour Yasmine, marhaba bik.
Bonjour, je vais me présenter, je suis Yasmine Drassini. Alors, je suis bioinformaticienne à McGill et travaille à l'Université Bebzouar. Donc, je dis bonjour à toutes les personnes qui sont à l'Université Bebzouar. Et je m'occupe de marketing et communication manager à management au Emax.
Parfait, merci beaucoup Yasmine. Alors, merci beaucoup Yasmine. Voilà, c'est le deuxième webinaire technique qu'on présente. Aujourd'hui, le sujet, ça va être Edge AI Applications Mobile and Construction Industries. Donc, on a des invités qui vont vous parler de ce sujet très, très intéressant. Et pour une deuxième fois, en fait, aujourd'hui, cette fois-ci, on a vraiment la chance d'avoir des co-hosts avec nous, des universités algériennes et des associations qui ont été très, très gentilles de venir porter assistance en fait à ce webinaire en partageant le live avec nous. Donc, on a d'abord l'association éthique qui est avec nous aujourd'hui, donc on les remercie d'abord, ainsi que le comité organisationnel de cette association. C'est une organisation estudiantine qui est créée en 2009 à l'École supérieure nationale d'informatique et qui a le but de faciliter l'intégration des étudiants au monde professionnel ou bien au monde entrepreneurial. Donc, j'ai mis en bas leur site web. Je vous invite à les visiter. Ils ont aussi une page Facebook qui est très, très intéressante. Leur contenu est très, très intéressant. Donc, n'hésitez pas à aller voir leur site web ou leur Facebook. Par la suite, je vais passer à School of AI, School of AI Algiers, qui est avec nous aujourd'hui. Donc, on les remercie encore une fois. Merci beaucoup de faire partager ce live et ce webinaire avec nous. Donc, School of AI, it's a local community of Algerian developers, students, and AI enthusiasts that teaches AI. Tout comme l'éthique, ils ont un site web et aussi une page Facebook que je vous invite à aller visiter. Ils ont du contenu très, très intéressant et très enrichissant, qui est vraiment focus sur le AI. Et pour finir, on a le Open Minds Club. Donc, merci à Open Minds Club d'avoir aussi partagé cet événement. C'est un club scientifique étudiantin de l'USTHB, créé en mars 2009, dont le but premier est de promouvoir l'esprit de partage et open source, qui est un sujet très, très intéressant. Donc, ils ont un site web que j'invite tout le monde à visiter et aussi une page Facebook. Pour finir, je voudrais aussi rappeler à tous les autres groupes ou tous autres responsables d'associations étudiantes ou d'associations technologiques en Algérie on garde toujours la main tendue. S'il y a une association qui a envie de faire partie du projet, en fait, partager avec nous les futurs webinaires qui s'en viennent, Inch'Allah. Ça nous fera plaisir de travailler avec vous et de vous ajouter, tout comme on a ajouté Open Minds, Ethic et School of Algiers, School of AI Algiers. Donc, merci à eux une deuxième fois. Donc, je vais aussi parler un peu des questions qui vont être possibles de demander à la fin du webinaire. Donc, tout comme le premier webinaire, nous allons vous permettre de poser des questions à la fin. Donc, n'hésitez pas, le premier, alhamdoulilah, on a eu beaucoup de questions. N'hésitez pas à poser le maximum de questions. Ce qu'on va faire, c'est que vers la fin, on va directement les partager avec nos présentateurs d'aujourd'hui, qu'on est très, très heureux d'avoir. Si jamais vous voulez poser une question à quelqu'un en particulier, n'hésitez pas à mettre son nom au début ou à la fin de la question. Et moi, ce que je vais faire, c'est que moi ou Yasmine, ce que je vais faire, c'est qu'on va choisir la question et on va directement l'orienter à la personne à laquelle vous voulez l'adresser. Donc, avant de passer la main à Sofiane, qui est avec nous aussi aujourd'hui, je vais rapidement présenter nos, euh, nos conférenciers d'aujourd'hui. Donc, je vais commencer par Ahmed Boudissa, docteur Ahmed Boudissa. Bonjour, marhaba bik Ahmed. Merci beaucoup. Alaykoum salam. Donc, Ahmed qui est très gentil, il est actuellement au Japon et il s'est porté volontaire pour faire partie de ce webinaire qu'on remercie énormément. Donc, Ahmed is a senior computer vision engineer at OPPO Japan Research Center in Yokohama. He's currently leading the depth sensing and also the multi-camera algorithm for the OPPO smartphone. So anyone who has an OPPO smartphone, Ahmed probably worked on something there. So this is you guys better listen to what he says. So prior to that, he received his engineering degree at INELEC in Boumerdès, Algeria. He also completed his master degree at École supérieure d'ingénieurs de Poitiers en France. and finally he completed his PhD from the Kyushu Institute of Technology in Japan. Donc مرحبا بك encore une fois Ahmed, merci d'être avec nous. بارك الله فيك, شكرا. Now, our next guest is Marco Herbst. Welcome, Marco. Thank you for being here. Marco is in Ireland right now. We really thank you for being available with us today. So, Marco is the CEO of Evercam. Prior to that, he founded a website called jobs.ie that got sold in 2004, and now he's CEO of Evercam Construction Camera. So Marco's history with AI in Algeria started in 2018 when he met with Ilias Dahi, which is our third presenter today that I'm going to present pretty soon. And this is where they founded. This is where they started this project. Now they're employing 9 developers. 7 of them are in Algeria, and 2 of them are currently in Dublin. So thank you, Marco, for being with us today. All right, now let's jump to our final guest, Ilias, Dr. Ilias Dahi. Welcome, Ilias, مرحبا بك. All right. So Dr. Dahi, he's a head of AI at the Evercam in Evercam in Dublin. That's the company that Marco founded. We just talked about him him and Ilias. So he's currently focused on applying AI and computer vision to solve problems in the construction industry. Prior to that, he received his master's degree in computer engineering in the University of Sidi Bel Abbas in 2012, and he also received a PhD from that same university. And his subject was event detection in video surveillance. So, thank you so much again, Ilias. يعطيك الصحة كراك معنا اليوم, بارك الله فيك. Now let's jump to Sofiane, who is also with us today. Thank you, Sofiane. مرحبا بك.
Thank you.
So Sofiane was also there, if you guys remember, at the first webinar. We really thank him for being available today too. So what's going to happen now is I'm going to let Sofiane continue and carry on with some interesting information on the project and also on the subject. So you have the hand, Sofiane.
Thank you very much. السلام عليكم. بسم الله الرحمن الرحيم والصلاة والسلام على أشرف المرسلين. قبل ما أعطي الكلمة إلى الإخوة إلياس وماركو وأحمد، أود أن أذكر واحد من أهم مبادئ هذه المبادرة، وهو مساعدة الطلبة لتطوير أنفسهم في مجال الذكاء الاصطناعي محليا في الجزائر، وكذلك وترجمتها إلى مشاريع اقتصادية، ستارت ابس أو مؤسسات. وليس الهدف منها هو مساعدة الطلبة للخروج من الجزائر وتطوير أنفسهم في الخارج. رسالتنا واضحة، وهي الأفكار متاحة للجميع، التقنيات متاحة للجميع، ونحن هنا لمساعدتهم إلى تطوير أنفسهم محليا. ليس إلا وممكن أن نذهب إلى أبعد من ذلك من خلال ممكن جلب استثمارات خارجية في هذا المجال من خلال تطوير أنفسنا وتطوير الإنسان، وهذا ما تسعى إليه كثير من الدول. وجود ماركو معنا اليوم هو أحسن مثال وأحسن ممكن نعطيه في هذا المجال، وهو وممكن أشكره جزيل الشكر لأنه قبل أن يشاركنا تجربته في الجزائر. I have to say the same thing in English because we have at least we have Marco. And so first of all, before giving the stage to our guest, I would like to remind one of the main principles in our competition, which is localization of technology development. So our hope is, or our aim is to help and support our students to develop their skills in advanced technologies in general and artificial intelligence in particular locally, and translate these ideas and skills into business and startups and enterprises. We can go even further than that by attracting big players in the world to invest also in our country. And Marco is a great example of this, and and I would thank him for accepting to share his inspiring experience with us. So with this, I will give the stage to Marco. Thank you, Marco. Welcome. And here you go.
Merci. Great to be here. Thank you all. And I would start by saying congratulations to anybody who is tuning into this or watching this on video, because you're already very much on the right path. I will only speak for a short bit and then hand over to Ilias, who I think has the more interesting things to say this evening, because he's really deep in the technology. But I thought I would give you some background to our company and to how myself and Ilias started working on this. I've been working with cameras for about 10 years. And for most of those 10 years, for 8 of those 10 years, really, I spent most of my time, and this is a terrible thing when you work with cameras, because you meet a lot of people who've got some funny idea about something the camera could do, some new business opportunity, and most of them aren't possible. So for about 8 years, I found myself always saying again and again and again, sorry, it just won't work. It's just not possible. And now, like at this moment in history, for the first time ever, suddenly these things are possible. We can now do things reliably that work, and not just in a very kind of laboratory controlled environment, but in the sort of place where we're working, like on building sites. These computer vision applications are finally working. And it's a really, really exciting moment in history. So like, congratulations for being at the right point at the right time. Right now, you're in a good place. What I will do, Ilias, are you able to share some of our slides, and then I'll just give you the very basics of what our company does. I mentioned the word construction.
Yeah, you can go ahead and share.
Get it up, great. If you can't, I can explain it as well. I mentioned the word construction. Essentially, yeah, we're seeing your screen now. Yeah,
see my screen, guys.
Yeah,
great.
Perfect. Thank you.
Jump on, Ilias, to the next slide, if you can. Every good business sets out to solve a problem, and the problem that we are looking at is why construction so often goes wrong. And that's true sometimes if you're getting a guy to fix your kitchen or you're building a new airport. The same things happen. There's a lack of trust. Unexpected things go wrong. It ends up costing more. And this is a global issue. And our belief, if you jump onto the next slide, Ilias. And one more actually. Skip that one. Our belief is that there's a relatively simple solution to that problem. Is if you can see what's going on, if you're actually aware of what's going on the site, either through images and pictures, which is where our company began, or now actually through data and reports and alerts and events, you can see what's going on and you can communicate with the rest of the team, less bad things happen. Really as simple as that. And when I think about how we explain our use of AI, I think back to how Google, as one of the pioneers, spoke about that they weren't going to be launching AI products, but AI was going to be in all of their products. And I think that's the message you'll get from Ilias. He'll just show you how there's almost no part of our company that hasn't somehow been touched or is being touched by this new technology. The final thing that I might just tell you is the simplicity of the story. So we were literally just putting cameras on construction sites. I was very fortunate one day searching on LinkedIn to meet Ilias and get talking to him. And we discussed essentially just some of the possibilities of the technologies that were available. Ilias was coming to the end of his PhD in Sidi Bel Abbès, and we decided to start working together remotely with Ilias staying where he was. And then as we realized the size of the opportunity of what we were working on, and we got deeper and deeper into it, and Ilias was prepared to come over to Ireland, and things got really serious, and the company has grown a lot since then. And we're now about 50 people in total in the company. Yeah, it's really, really escalated. And I think there's just no shortage of problems and industries and places where these skills can have the same effect. They can take a simple problem a whole new type of technical solution. I have to say now, since COVID, Ilias took the opportunity to run back to get his mother's cooking back in City Belevez, and I'm hoping we can talk him back to coming to Dublin. He might be waiting for winter to finish. I'll hand you over to him to talk through some of the more interesting details. And the final thing I would say, because I won't be here for the Q&A, but Ilias will be, is please, you're very, very welcome to reach out to either of us outside of this webinar. Yeah, I'm easy to find on LinkedIn. Our company is easy to find. And I wish you the best. It's a very, very good starting point that you're at, and the relationships you'll build here, and the technologies that you'll start to work on, they have a great future. Thank you very much.
Thank you, Marco.
Thanks, Marco. Should I jump directly, Hussein?
Yeah, go ahead, of course.
Yeah, thanks. So hello, everyone. So this is Ilias Dahi. I will talk a bit. First, I will start with a bit of history from Evercam. So from 2015, Evercam has been installing CCTV cameras on construction sites. And this means generating a lot of data, video data from construction sites. So like from 2015 to 2018, we had installed almost 300 cameras on different sites, island, and all the parts of the world till now. So you can imagine the amount of data that we had. From 2018, when I joined the company, we started looking at that data, and we realized that we are never going to annotate or label this data for training the model. Otherwise, we just need like 1 million of annotator to work on this data set. So this is the goal on 2018, understand like what's happening on this construction site, and the goal for us on 2022 is to have a tool, the ultimate tool that can be used by project managers for cost reduction and risk management, using this high-level data that we can generate from computer vision, and like also compare with models that I will talk more details in the next slides, and you can understand what I'm trying to say. So this is it. We had on 2018 with master sites, and that's the first problem I'm going with history. So the first problem is how we are supposed to label this amount of data. So the first, our solution was that we will try to get a sample from that data, a sample data set from that data that represent most this big data. So we started by adding rules when scrapping the data set, for example, at what time of the day, year, season, and we are going to scrap this data. For example, if we're scrapping our data and only like from the night or from the morning and midday, so we try to balance data scrapping from all the times of this day. The same apply to months, seasons, and year, everything. The second rule is camera view angles. We try to balance, get data from all camera view angles. The third one is class variance, which is we have in the same class we can have objects that have the same color, for example, or the same shape. So we try to just by using this is done by human. So we try to have as much variance as possible on the same class. And the fourth one is inter-class imbalance. So we try to avoid that by doing analytics of some discrepant data sets by having the same amount of data on the same amount of data for all the classes. That's we call it smart sampling. So we do analytics on our data sets, and then from the conclusions we have, we go to the data and scrap. And all the done scrapping is that we think it will remove the human biasing when scrapping the data, which is use these conclusions and then go to the data set and try to scrap the data that is needed for our data set. And also, one last thing that can help us speed the process is auto annotation, which is like from the first time we had our model ready, we just used that model to also generate labels, and like labels that are below a threshold are just pushed for annotation, and the other labels are just the other objects are just not annotated again. And like just also one last information is for our model for equipment, construction equipment detection, we have 24 classes from 24 classes of the most common construction equipment that you can find on construction sites. We have annotated almost 2 million point five objects for our data set, and that's only using 3 annotators, and for I think something like 8 months or 10 months. So I will jump to the next slide. In the next slide, in this slide, I will just talk about one example of application where computer vision and deep learning has proven that efficiency for or usability in the construction industry. So this is we call it this feature or this product, we call it the gate report, which is like just having we try from the customers, we got the impression of the customers that like they want to know what come into the site and what leave, and how much time they spent, like the trucks, how much time they spent on site, and what type of truck has entered at that time, and company has delivered, so which company has delivered mobile crane, etc. So we use our model which has like 10 classes of trucks from different types, and we track all the trucks the moment they come into the site, and we just stamped these events when they arrived, and we track them, and once the truck is leaving, we just push that event with the time arrived and left. And like just give you some examples, like not examples, but just some details. So for example, as you know, a construction site is a complex environment. It's like there is a lot of occlusion, and it's hard like to keep track of objects. And so one trick we do is we use some when the tracked object is lost at the leaving event, we just use other features to identify which trucks, which leaving events correspond to the entering events. So for example, we use embedding distance, which I will talk about in the next slide, just a visual similarity between the two objects. We have a parameter or average time spent on site. So for example, as I said, we have a tracker for each class. We just have an average time spent on site for the last week, for example, for the last week for some class, and then we use that average time to see if difference in time between the two events is not.
Ilias, if possible, sorry to interrupt you. Is it possible just maybe to speak a little bit louder?
Yeah.
I think that
sure.
would be very nice. Thank you so much.
So we use also, as I said, how much time has spent, and like there's the class also of the truck. That's obvious, and also there is the ordering queue. So we stack them also in a FIFO queue and try to find the one that is the first that has arrived is obviously the first that will leave. That's one parameter. So that's just an example how we use object detection and tracking for in construction site for deliveries detection. So this is an example on how the gate report feature or product looks like on our dashboard. So you can choose which class, and you have all the events, what time and have left arrived, and what time they have left, and the time spent. So this information is actually very important for a project manager or quantity surveyor. And you can imagine, like sometimes it's like about 150 events per day. In this slide, I will just explain how we do, or I'll just start from the beginning. We talk about how we do truck company identification. So we want to know, for example, the customer want to know which company has delivered concrete at some time, and we want to give them that information. One technique we can apply is classification, but we don't have a number of class, a predefined number of class, so it can keep growing while we have like more customers. So what we do is just we apply triplet laws, and then we train with the classes that we have, and we train a model like that can make a difference between objects rather than classifying objects. And this is the same technique used for FaceNet and for face recognition. And there is an example on the right of how, for example, 3 classes are clustered when you use triplet laws. Once you want to, for example, identify which company, you just have to extract the embedding of, for example, the carpet truck and compare using Canon on the embedding space that you have created from your truck samples. So the next application, the next example application is equipment monitoring. So we have our model, and it's working well on the construction site. And one thing the customers want as well is they want to know each equipment, how it is performing on site, and how much time it has been working for the last hour or for one day, and also like what time it has arrived, etc. So like we have built tracking, also like the same tracking algorithm, and is used to track every object on the site and have an estimation of time, how much has been idle, active, idle, or on screen. Like you can see mobile crane, pile drilling rig, anything that is an equipment on the construction site. So on this slide, I will just give an example on how we use gate report at the edge, how gate report is deployed on edge. That is deployed only on one site. Sorry. This is deployed only on one site, and the whole system consists of 3 main components. You have the dev environment, where you develop your model, you train your model, you deploy your application, and then once you have finished it, you just push. You have, like for example, at the cloud, you suppose in Evercam, for example, we have a model up, which is just a bucket in S3, where we store our models, and also you push your API to grab, for example, Docker image, or you can store it also on AWS ECR. And once this done, you have on the left at the edge where we deploy like our camera with an NVR and a 4G router. So to say like we have an application that is running on the edge, we just deploy with an Intel, and we just have deployed an Intel computing unit, and you see plus an NCS2 neural computer from Intel. And how it was, it just like we have like mechanisms that when the Intel box is powered, you just pull the last image of the application from Docker and the last models and start running and doing analytics. And everything happen on the edge, and only event that when there is an event, it will be pushed to the cloud or database. Usually, applications that are deployed on the edge, when they want to store the events to the cloud database, they use a protocol called Kafka for event streaming. But this is this is used when you have like a big stream of events flowing from the edge to the cloud, and you don't want to miss anything. But in our case, like we have like our most critical case is 150 events per day, so we are not really worried about missing events. And there are 3 reasons why Evercam might or want to go at the edge, like want to deploy their solutions at the edge. First thing is saving bandwidth. We don't think it's a good, like for now, we are like just pulling streams from 4G routers in some area that is like far from city, and they have like bad signal. And everything, and we're just pulling streams, and this is really, I think it's like just not convenient. That's the first reason. The second reason is GDPR compliance, which is like GDPR just standard in Europe, where don't have like, there is like some rules and restrictions how to use public data. So if we deploy our analytics solutions at the edge, we will just be GDPR compliant and we will not have problems with the state or anyone, officials. And the last thing is achieving real time. For now, our solutions are not really real time, and like they can range from 2 hours to 1 day delay. And we want to achieve real time because this is like, I think that customers are more interested in having real time high level information of what's happening on site. So this is, we jump next slide. So this is how like our how the Intel solution is deployed on site. That's just demonstration, for an example of deploying at the edge. So this is like the router, the NVR, the Intel computing unit, and the neural computing sticks. At last, I will talk about some challenges and nodes that I think that are very important in applying computer vision practice. The first thing is, I think before or when you start a computer vision problem or AI problem, you have to think about maintaining your models. Who is going, like there is people who are going to develop a solution and then jump to the other thing. That's what they think. But you have to think about who is going to maintain the models, because like you have to be sure that at some point there is a scenario where your model will perform very poorly at some point in time. And you have to know how you can recover quickly from that situation or even prevent it. Which I think it's still gonna, so we really think of things. Productization as well. Who is going like also to take care of solution productization, like deployment, as I said, maintenance and everything. That's these kind of things. You have to think about them from the beginning. And like you can make, I think if you think about them, you can make good decisions before starting. You can have a plan of how you will make productization of your product. The third point is early demonstration. I think if you have any computer vision solution, you can demonstrate it visually. So as soon as you have a solution or a model, just deploy it on an endpoint using like Fast API, make some UI on the interface, UI interface on the web, and just deploy it. So you like people, shareholders, or your maybe potential customers, or like anyone can check your model and can have an impression of how it will work or have a taste. 4th point is I think scrapping annotation and dataset management will take 50% of any serious computer vision or AI project. I think that's a must. And at last, I will just, I think if you want to start, if like students want to start on computer vision projects, I think CVAT from OpenCV, which is like collaborative annotation tool, I think it's a great tool for you, and you can deploy it at some, static IP, and you can hire people, or even between your team, you can work on the same project at the same time. Thank you very much. That's all from me, Hussein.
Yeah, thank you, Ilias. I think, first of all, thank you so much for this presentation. I think now is the time for Ahmed to start sharing. I don't know if you're ready, Ahmed. I can take your document, whatever you're ready. Oh, I think you're muted, Ahmed. All right. Yep.
Assalamu alaikum. Can you hear me?
Yeah, we can.
All right. Well, thank you everyone for taking the time for being here tonight. This is Ahmed, and I'll be talking about the mobile industry. I think it's gonna be a little bit less serious than what Ilias was doing. The subject will be quite familiar with a lot of you guys. I think everyone in their pocket now have a smartphone, and yeah. Sorry, are you able to see the slides?
Should I go here?
Okay. No, I think you just Ilias, you should just stop sharing, and
Yep.
in theory I'm sharing.
Here we go. It's coming. You can just put it at the. Yeah. Here we go. Thank you.
All right. Okay. Sorry. So I'll be talking about basically the use of AI in the smartphone industry. More specifically, we'll take one example, and we'll try to go through the process of how we develop such algorithms, what kind of problems, what kind of considerations we need, and I'll try to give some practical development points on that one. Obviously, it's a very wide subject, so let me just start at the beginning here. And as they say, let's call a cat a cat. So first of all, whatever we are doing in the deep learning or computer vision, it's not really AI. So what's AI started the hype in the 60s or the 50s, the Terminator and the robots, and that AI is gonna take over. So whatever we're doing now, it's way, way, way far from that. So what we're doing is just trying to solve a lot of equations using a lot of data. So it's not AI, so you don't have to be afraid. It's just a lot of math, a lot of programming, a lot of computation. So even if it's not AI, though, it's still very innovative. You can do a lot of things with it, and it's relatively new field, especially the convolutional neural networks and deep neural networks field is quite recent. And basically for every solution, even the easiest, even the most obvious problems, they do not have a final solution that says, no, we have the solution to this problem, or this is the way to solve this problem. So it's still a Wild West, especially for young engineers. You don't have to be intimidated. Compared this to, let's say, the more classical fields like physics or mechanics, this field is still really, really very innovative. There's a lot of stuff that needs to be done. So for young engineers out there, I think you still have a chance to get your foot in the door and do a lot of interesting stuff. Obviously, it's hard. It's hard in many ways. It needs some mathematics. It needs some programming. It needs some hardware, some resources. But yeah, it's good to know that it's hard. So it means that it's quite selective. So if you work hard, you'll be able to achieve something. And the fourth point, and I think especially viewed from the industry, it's very, very slow. So getting AI or deep learning to work in the edge is still the exception, actually. So most of AI algorithms are run offline, trying to make sense of data, trying to find patterns, trying to analyze something. So the exception is that it is able to run on, the exception is that it is able to run on the edge. And that's why companies like NVIDIA, Intel, Qualcomm are trying to make specific hardware so that AI is able to run on the edge. And it's also quite dumb, actually. So when I say dumb, it means that it just does what it was programmed to do for a lot of applications. So that's just trying to take the fear away from this big word, the AI word, which is quite very generic. So now what we'll be talking, or what everyone is going to be talking about, is actually a very narrow area of this artificial intelligence, of machine learning, of computer vision, which is the deep learning part. So the deep learning part is the latest hype here, and that's what we'll be talking about. So just to summarize it, so what are deep neural networks? They're actually just a lot of equations. If we had a lot more time, we could explain and make analogies with more familiar concepts. But it's good to start at the beginning. So it's basically we're trying to find, for a specific problem, we're trying to find the least worst solution using as much data as we have. So we're not trying to find the best solution or the solution. We're just trying to minimize the error. We're just to put ourselves in the least wrong position possible using as much data as we have. Okay, so now that we got this one out of the way, if everyone takes their smartphones today, I think it doesn't matter which maker, and you switch on the camera, you actually have a heap of AI applications already. So for your selfie camera, you probably have some face beauty settings. You have probably some AR stickers trying to follow your face around. If you have a little bit more expensive phones, you probably have face unlock that's trying to recognize your face in 3D to unlock it. Using your dual cameras, you can have probably some depth sensing. If you take a picture, it's gonna be smoothly blurred. So that's the effect what we call bokeh. And we have scene recognition. So for the scene recognition on the right here, let's say you're taking a picture of a sunset or food or of your kid or of your friend. So the usually the color spectrum or the color balance, the best one is different for each scene. So for these kind of scene recognition applications, basically we try to recognize what kind of scene is being taken and then apply a certain color filters or try to adjust the white balance or other settings on this one. So just already in your pocket, you have a bunch of AI applications. So for today's presentation, from here on, I'm going to be taking one example. I'm going to take you through basically the process of developing that example specifically. So this example here is what we call the large aperture or the bokeh effect. So in recent phones, I think whether for your selfie camera or your background camera, if you start the portrait mode, what's called the portrait mode or large aperture or virtual aperture in some makers, basically it tries to blur the background and keep the main subject in focus. I think this one is this option is also available now in even conferencing software like Zoom or many applications. So the goal here is that if you're an adept of photography, you'll get the DSLR. If you get a very large aperture, you can focus on object, and then you have that smooth, that creamy background with beautiful round spotlights, and then you have your subject that's sharp and in focus. So the goal here is that with the smartphone and with this small camera, with this small sensor, we try to basically mimic that effect and even make it more interesting if we can. So we try to use some computational photography. So the how is that we try to use some computational photography. We try to use some classical computer vision techniques. We even use some computer graphics techniques to try to recreate that effect, that blurry background, that creamy, smooth background, while actually being able to do even more. So if we can take an example here, we have an image on the left. This one is already a little bit blurred, but let's say this one. So our goal here would be to try to find a mask, find a segmentation mask for that subject you're trying to take a picture of. And then once we have a separation and that we know which pixel is which, whether it's your subject that you're trying to capture, or it is a background, we can do a lot of processing both separately on the foreground and background, and then you can merge them. So you can do like this kind of portrait-like processing. You can do like this, the bokeh. The bokeh itself, the bokeh itself is actually a Japanese word for just to mean blurry. So, and you can do a blur separately the background. You can replace the background. You can do a lot of interesting effects. So this is basically the core of what I'll be talking about today. So this step specifically, so the AI part or the deep learning part here is gonna come in when we're trying to detect these pixels, the mask here, the one where it basically decides whether it's black or white or even in between, whether it's foreground or background, whether it's subject or not. So it's building this neural network. But as all of you know, usually neural networks are quite slow. So what we do is that to minimize the number of pixels that we're gonna be processing, we just start by running a face detector. So we run a face detector. So if we have a face, we're gonna try to crop around it, square around it, so that we minimize the number of pixels we have to process, and then we run it. So this obviously depends on the applications. There's a lot of things to consider, but just something to keep in mind. So now that we defined our problem, let's see how would we go on trying to solve it. So first, when you start to prepare, as you know, for any deep learning application, you're going to start with trying to define what you want to do, what this network that you're trying to build, what it does. So for us, the keyword here is going to be to segment an object from an image. So basically, we take an image, and for each pixel, we're going to have a decision, or at least a probability map of, is this pixel the object that we want, belongs to the object that we want to segment or not. So, and all right, this seems to be quite straightforward. The next point is that what kind of object? So humans. If we're trying to capture pictures of humans, if we're trying to use this application specifically for selfies, let's say, so we want basically to separate these two areas in the image. All right. It seems to be quite simple enough. So are there any publicly available data sets? Yes, obviously this subject has been hammered for quite some years now. So if just Google it a little bit, you can find this PFCN data set, the Supervisely, the COCO data set, and there's a different, each data set was built for a different purpose. So there's different ways of labeling them. Then you find the poses, you find even the human parts labeled and everything. All right, so now that we have all this data, so which one is best? Which one would fit best for our application? Which one is good? And how do we know if it's good? And that's a good question, actually. So how do we define if a data set is good enough for an application? Right? Is it the number of samples? If we have just 100 images, is it enough? Do we need 1 million images? Is it the resolution of these images? Is 64 by 64 enough? Or do you need 3000 per 4000? Do you need a 4K image? Is the precision of that labeling, is it the correctness basically of this labeling that's key in this case? So for example, in our portrait segmentation or in our human segmentation, you see that there are two wildly different ways of labeling this data. So on the left here, we can see that the segmentation is basically 1 hair each. So it's very, very precise labeling here. But on the right, it's quite rough. We just have a couple of basically blobs. So it's blobs that contain the subject in the image. And the answer, obviously, it's never straightforward. So it all depends on our goal. So if at this point we already got the data and we don't know if it's good or not, I think means that our problem definition was not clear enough, was not good enough. So let's go back to the problem definition and try to give it more detail. Usually this will take you a lot of time actually before you actually start doing some training, or it could be before you start doing any actual programming, trying to analyze your problem and trying to actually define the task that you want to achieve as clearly as possible will take you very far away actually within the project, because it's gonna help you filter out a lot of useless information. So we go back to the problem definition. So our goal is to segment an image for humans. And what for? So we want basically to blur background or to do some image stylization. All right. So if this application is basically to create images, if we want to create images, so the edges of this mask and the pixel wise, the visual quality of the image is very important. If we were just trying to do some statistics or trying just to count, or trying just to, let's say you have an image and you want to count how many people, that wouldn't matter, the pixel level quality. But in this case, you're creating an image which is, the main goal is to have something visually pleasant, visually good. So the quality.
Just a quick comment, Ahmed. Is it possible just to remove the panel that is just after cropping? So one of the steps we have camera face detection, then cropping, then there's like a small panel on top of your. It's the
Okay,
share
okay. All
notification. I
right,
don't know
sorry.
if you see it. Yeah,
Okay,
this one.
thank you.
Thank you. Yes, so much you missed. Thank
All
you.
right. So, as I was saying, since this is mainly a visual application, so the visual quality, which is basically what's going to be evaluated at the end of the day, is very important. So the edges, once again, and let's start adding some limits. We don't want, and there is no almighty algorithm. There is no algorithm that's gonna solve every problem for every solution. So let's start putting some limits. If you're developing this kind of algorithm for a selfie, so it's usually about from 50 centimeters to about 100 centimeters, so about less than 1 meter. If your arm is very, very long, it's gonna be about 1 meter. Even if you use a selfie stick, it's gonna be a little bit more. But let's say it's about 1 meter. I'm putting a number just here out there. It's about, let's say, the face, the number of pixels in a face is going to be about 500 pixels maximum. All right. And then how much processing time do we have? And this will actually decide on a very big chunk of your work. Because if you're doing something with unlimited processing time, you can do a lot of fancy stuff. There's a lot of open source out there that's good quality, especially in the academic side. That's quite interesting. But if you're going to run on the edge for users, for customers who are who are always in a hurry, who can't wait for a web page to load for 2 seconds, who are used to very high speed processing, you can't make them wait. So in this kind of situation, let's say we have 1 second for the whole process. So from the moment you take the picture to the moment you see it, let's say you have about 1 second. So if you're trying to separate it between all the different steps that you have, they're going to have about 300 milliseconds to do face detection. Face detection has been embedded now in a lot of hardware, so actually you're going to need a little bit less. We're going to have about 300 milliseconds for segmentation. Let's say we take a little bit more from the face detection, we give it here, so let's say about 400 milliseconds. And then you have about 300 milliseconds to do the blurring of the background. And you can see here that the blurring is not just some Gaussian or some box filter. It's quite some sophisticated blurring. It actually it might take some more time. And since the images are big on smartphone, you're usually working on the 12 mega images, so it might take some time. So we're on the ballpark of about 300, 400 milliseconds. All right. I think now we have defined some more specifications that will help us choose the data and the network later on. All right. Now let's go back to our data. Now that we said that we need precise edges, so we need precise edges, doesn't mean that this data, like the supervisedly data set, is not useful for us in this case. People are too far, a lot of people mixing up, and the labeling quality is not good. For Cocoa dataset, you might take maybe parts of it, but if you can see here, it's also just blobs segmentation. So it's actually also not that useful for this specific application. For the PFCN, actually, it was gathered in I think 2017. It was gathered for this purpose specifically. So as you can see, the quality of the segmentation here is really good. There are obviously some more matching and some more precise labeling data set, but let's say we start just with the PFCN data set here. All right, so now that we got our data, let's try and choose our network. So obviously, once again, there's a lot of networks available out there, and what I'm trying to show you here is just try how to narrow your search in the beginning. And this is what I'm gonna say here is definitely not the final answer. This is not the best answer. So what I'm giving you is just trying to analyze and the importance of just knowing the big headlines for each type, for each backbone of network, what they do, what are they good at, so that when you start your search and you start eliminating before you try to download any open source or any model, before you start testing, just to know your direction or what you're going to be needing. So here, if you just Google quickly, you're going to find that there's the FCN architecture, which is transferred from VGG. There's the ResNet architecture, and there's the UNet architecture, which are more or less popular. All right. So if you try to analyze basically each one of these architectures, for the FCN, it was made for segmentation at the beginning. It's quite simple to implement and train. The final model is relatively small, but actually the output itself is quite low resolution. If it's low resolution, it means that we don't have a very good edge precision. All right, so it's not meant for our application. If you go for ResNet, the core for ResNet was the training stability, so you have the residual blocks, but it's actually really big. So for ResNet 150 or something like that, you won't be able to run it in 300 millisecond, nor on the edge. So you're going to have to do a lot more work to be able to run something like this on the phone. So for a UNet, it's quite generic. So UNet here with skip connections. So the first thing is that it keeps a resolution, the resolution of the output, and it keeps good edges, especially for the skip connection. So that's quite good. The cons, so since it actually downscales and then upscales, it encodes and decodes. In the smaller scale, sometimes gradient is a little bit too weak, so the training might suffer, but that's not really a big problem. You can worry at it once you have a very good thing going on. And the main thing with UNets is that the fact that there is encoding and decoding, so there's the minimizing of resolution and the upscaling, so there's a big value in the processing time over there. So actually, for a lot of applications where the quality of the edges and the resolution of the edges is important, a UNet-like architecture is usually recommended. All right. So now that we have our data set, our network, the training seems to be straightforward. All right. As I said in the beginning, training itself, or trying to teach the machine, trying to teach this network, basically to minimize the error. So we have a prediction that the network makes, and we have a ground truth data that we want to bring this network to be as close to it as possible. So we're trying to minimize this error between our prediction and this ground truth data. Ideally to be zero, but we just want to minimize it. So if we just take a difference and we divide by n the number of pixels, that is one way to do it. But the question here is, should we give all the pixels in the image the same weight, the same importance? Obviously, if I'm asking the question, it means no. So what I mean here is that, as I said, the edge pixels are very important for us in this kind of application. So, but if you analyze statistically your data set, you find that there's less than 0.01% of the pixels are actually edge pixels. So if there is just really this minority of pixels within this huge data set, so actually the training will not tend to give them that much importance. So it's going to give importance to the overall look of the segmentation, to the overall look of the final mask. So that's why we're going to try and push the network and tell it, you know what, those edge pixels, even if they are a minority, their opinion still matters. It actually matters more than the pixels inside, and we basically implement this sort of weight maps to try to push the error weight in these edge pixels, to try to give them more importance, And actually, this one is works a lot. And to be honest, this technique specifically about the edges and how important they are, it's not really new. It's not really unique to the deep learning networks. It's been used since many years ago, actually, for optical flow and for a lot of applications. But this is just one thing to keep in mind, especially when you're doing your training. Sometimes you have your network right, you have the good data, but usually the training doesn't go right, and it's just hard to find. But that's why it's quite important to pinpoint even your loss, the way you build your loss functions. It's very important, and you can see here the difference in the results here. The two columns in the middle, they do not use a specific weight for the edges, but the one on the right uses, and you can see a big difference in the results in the edges here. So this is basically what I had to do, what I had to say for this for this application. So once you do your training, we're able to get these kind of results. These are from OPPO phones. So you can see here on the application on the left, once we're able to segment the human from the image, you can do this stylization. So you keep the human in color, the background in black and white. On the right here, once you have a segmentation, you can apply this bokeh or this blur filter, the circle filter on the background, and you can see that it changes completely the effect of the image. It doesn't mean that this problem is already solved, even though a lot of engineers have been working on it for many years now. But it's definitely not a solved problem. It's definitely not a closed case. That means that even you guys can still make an addition into this problem. When I say here, these are images taken from more than $1,000 phones. It means that really companies are putting a lot of efforts, a lot of money, a lot of resources, a lot of data in trying to make their product as good as possible. But still, these algorithms have some failed modes. So you can see here the hair and the vest here are failing, especially at low resolution. You got around the hair, and especially when you have some hats or you have some repeat texture, it's always an issue. So this is still a research subject, and we're probably going to be hearing about better research and better results in the future. So once that we have this segmentation, if you can think of any application, I think there are a lot of open source models for human segmentation, and you can do a lot of it probably. And the next step for this one would be, what if we want to do it for video? Is there a different approach? Should we do it just each frame individually? So this is a whole different subject too. So yeah, this is just some ideas worth exploring, I think. So finally, I just want to give some practical points. So when you're running on mobile, so now if you have a mobile, whether it's iOS or Android phone, or even Huawei, you usually, if it's recent, you usually have this what we call the NPUs, neural processing units. So Qualcomm has its 0th NPU, Apple has it in its A11, and Huawei has it in its Kirin. So you have also some DSP, CPU, GPU. There's a lot of computing power. I mean, in 10, 15 years ago, standards, what you have in your pocket now is basically a supercomputer. So you really have a lot of computing power, and it's actually a very user-friendly and very developer-friendly platform. So even though what we call AI seems intimidating, and usually AI is associated with having access to server, having access to a lot of computing power, having access to a high-end GPU, PC, whatever. You actually can do this kind of stuff even just on your smartphone. You can start your Android Studio today and try to load. There's a lot of tutorials of trying to load models on your phone, trying to run some face detection, pose detection, segmentation. There's a lot of applications that if you can just try to get your feet in there just by using already built models, and you can start to play with them, try to tune them, try to improve them little by little. I think you'll go a very long way before actually needing to build your own data set or to label it to do that. That, of course, it needs budgets, needs resources. No one expects from students to have access to 2 million images and label them and to do all the fancy stuff. But you are expected to basically explore, try. There's a lot of information on the internet right now. If you're interested, I can give later on some courses on tutorials, some basic stuff where to start. But yeah, there's a lot of that a lot one can do just with a simple laptop and a phone. So as I said, let me just wrap up here. So you have your DSP, CPU, GPU, and your NPU in your phone. Usually, a combination of all of these is gonna give you the solution. Obviously, on your phone, the battery is very important. So for us, we're always worried about this one, about the heat, about these kind of problems. And the final point is that there's a lot of talk on 5G. So for 5G, is basically you're gonna have blazing fast speeds, upload and download speed. So if we're able to get from the moment you capture your picture, if we can get it to the cloud, process it, and get it back to you at the same time frame as if it's been processed on your phone right now, would it be better? Could we make cheaper phones? Could we make? So it's also a very big direction to explore, and there's a lot of work that's going into that direction. But this is a topic for another day, hopefully. All right, that's all from me. Thank you, everyone, and welcome your questions.
All right, thank you so much, Ahmed. It was very, very interesting. Like Ahmed said, we're going now to jump to the question part. So what's going to happen is that, just like I said at the beginning, do not hesitate to ask any questions on the Facebook. I really want to thank the people that already went through this and added a couple of questions to both. To you, if you have a question to Marco, Ilias is going to ask for it. Otherwise, if you have any question to Ilias, go for it, and also any questions to Ahmed, go for it. Before that, I want to thank Ilias, Marco, and Ahmed for their amazing presentation. You guys went very technical, and therefore we also have a lot of technical questions. So yeah, I think it should be very interesting to see. So the format is the following. What I will do is take from the beginning any questions and then ask them to anyone who is either interested in answering it, or if it's targeted to someone, I'll simply ask that person to answer. So first thing that I wanted to share, it's not exactly maybe a question, but there were very positive comments about the project that you, Ilias and Marco, are doing. So here's our friend Riyad Zinasni, sorry, who said, he likes your
Yeah,
project and he wanted to, yeah. So he liked, I guess, the project, and he wanted to give his uh, positive
actually,
comments. So,
actually, we know him. Both me and Marco, we
oh,
know him. Yeah,
got it,
just we have.
got it,
Yeah.
got it. All right. So thanks to him. Thanks for this question. Now, well, I mean this comment. I mean, now what I will do is pick up another question that was asked here. So it's this one. What are the most demanded skills for computer science engineer outside of Algeria? So what I will do, since this question came up before, I'm gonna go in order of appearance of questions. This one came before, and I'll answer that one. As I work as a computer engineer for IBM, I think it always depends on what you're interested in. If I had to give you one answer that will allow you to get a job super easily in any company, I will say maybe web development. So take something like JavaScript, CSS, HTML, some scripting, maybe Python. That'll be super interesting too. That will be the thing to go with. You will definitely have a good job in that field. But if you're more interested on the AI side, I think I would say C++ and Python, maybe especially Python, is the go-to for programming languages. Having understanding, I think at the end, Ahmed talked a little bit about cloud and 5G. Having understanding also of cloud development is very important, as we're trying to move, any company is trying to move as much as possible all their stuff into the cloud, for computation reasons and also for cost reasons, and it's been more and more popular, as you probably see with AWS from Amazon, or Azure from Microsoft. So I would say, if I had to summarize it a little bit, JavaScript if you're interested in web development, C, C++, and Python for the AI part, and having a good knowledge in cloud development will definitely open you a lot of doors. So thank you, Otaku Saku Ra, for this question. Now let's jump to another one. All right, we have one, maybe Sofiane, if you can jump in. It's this one. So our friend Malik Malik says, did you contact officials in Algeria, ministry, university, institution to offer expertise? And what was the answer? If not, do you think to do that? Thank you. So Sofiane, you can talk about it, and maybe I can ask Ilias and Ahmed later.
Yeah, so me contacting institutions, not now. Maybe I have, but we are in contact with, at least myself, with the main research institutions like CIRIST and CDTA. Also contact with some universities. Officials, yeah, in the past I was invited a few times by official institutions. This is happening less now, but yeah, I think we most importantly we are always we never say no for any request, definitely, and this one is one of them. We are trying to bring our contribution in different ways. Yeah, but yeah, we'll be open to any opportunity. Thank you.
Got it. Perfect. Thank you, Sofiane. Ahmed, would you like to maybe add a comment on that?
Personally, I haven't contacted anybody specifically. I think for now, we're basically, I think this is a very personal opinion, but we are working at a very grassroots level. We're talking directly to students. I think if we get this competition going on, probably in the future, if there's anything concrete or there's anything worth contacting authorities about, it should be done. But I think what's most important right now is to have this community, to have the community going on, and to have this network, to build this network first, and then we'll see about officials and stuff. But yeah, we're engineers and we want to share information, so we're here to do that.
Perfect. Thank you for your answer, Ahmed. Ilias, would you like to jump in and give a comment on that? Ilias, can you hear me? Oh, I think we lost. That's totally fine. What I will do now is, so thank you, Malik.
I think Ilias, just to say a funny thing, I mean, Ilias is maybe the closest one to authorities, because he had to go through a lot of administrative processes and with his company.
That's why I was interested in his question. So yes, I can give you a second chance if you're interested in answering that. Your mic is muted, so perfect.
Yeah, sure. Yeah. Personally, like when you say like offer your expertise, like personally, I don't think like there are many people, Algerians, who are like outside in Algeria that like know a lot better than me, and I think like building, like Ahmed say, building a community and like having them together in like, and I think that's the best thing that could happen for AI and students in Algeria. That's my answer.
Perfect. Got it. Thank you for your answer. Actually, Ilias, the next question is also targeted to you. So it was asked during your presentation. So it's from Nawal Meb. So does detection tracking algorithm work in challenging weather conditions? So we know in construction sometimes they build here they build in crazy winters. Sometimes the rain is very hard. So what is your answer to that?
So as you mentioned, most of the data sets is from Ireland, and have an idea of how the weather is in Ireland. So our data sets is more based to have bad weather condition than normal condition, and that's not a problem. That's like if you my answer is that if you have like in my thinking, like the network will recognize and detect what you have trained it to detect. So if you give it like a good data, anything like weather condition, like we have like situations like almost 90% occlusion. There are a lot of examples. Like for example, as you know, a construction site is a hazardous place, and like sometimes we have crane occluding like almost half of the picture, and it's still working because we have added the right data set, the right data, and also like adding a lot of data augmentation techniques.
Okay.
So I want to add something here, which is maybe related to localization of this type of applications. So basically, I mean, what Ilias was saying, that they have very challenging data coming from Ireland, which is true because of the weather of Ireland. But so the same application, if it is deployed in Algeria, it may not work well. So there will be some kind of I don't know, tuning that need to be done to adapt and localize maybe the application. I give you an example, like specific to pixel mapping for autonomous cars. So there are like big guys who are working in this area. They know very well that they can take a very successful system which was trained in London, but doesn't work when it's moved to doesn't work well if it's tested in New York, because of the different type of features, different association of features, and so on. So they have to retrain it, and that's why like reinforcement learning is one of the ways to tune and or transfer learning also to try to localize or adapt or type of applications.
Yep. Thank you for your answer. I think now that you know that it has been tested in Ireland, I think it should be enough of an answer to me personally. Thank you so much for both of the answers. So I will give the hand now to Yasmin so that she can jump maybe on other questions. So Yasmin.
Yes, I will jump, but yeah, he come back. I was thinking that we lost Ilias. So yeah, so the next question, sorry, is from Fouad Bous, who said, how to ensure the auto-scrapping process is not adding noise to the data?
This is for Ilias.
Targeting for Ilias.
Ilias, can you hear us?
You're muted.
You're muted. You're muted. Yeah.
Hello, Ilias, can you hear us?
I think we lost Ilias.
Sorry. Yeah.
Yeah.
You hear me now?
Ahmed, if you can.
Yeah.
Yeah.
I think. I said when I said when I say auto scrapping. Hello.
Yes.
Okay, so when I say auto scrapping, it's not like from internet. It's like from our own data sets, and like I'm not sure what you mean by noise, but for example, if that's the answer, like we don't like directly get our scrapped data in our for annotation. Don't just send it directly for annotation. You just first filter that data, like just visually quickly in a quick process, and then accept or ignore data that is suitable for our data set or not.
Perfect. We have another question for the same person. So it's from Fouad Bous again. He said, did you consider any data augmentation technique to balance your data? If yes, please cite an example of the use of the technique.
Like traditional data augmentation techniques, like random patches, image flipping, color shift, etc. So there's like last technique like we have used it is a mosaic technique, and yeah, that's it.
Perfect. Same question for the same for you, Ilias. So he said, what was the mission of embedding a space Which CNN backbone have you used?
Yeah, so the dimension for the embedding space is 128, and a backbone which work good for us is just mobile net. It's fast and it's like good accuracy.
We can't hear you.
Hello? Hello?
Yeah, I hear him. Yeah, I hear you.
Okay, so
Yeah,
it's okay.
I can repeat. So the dimension of the embedding is 128, and the CNN backbone is mobile net.
Perfect.
Which is like it offer like good trade.
All right. Thank you so much for your answer, Ilias. Yasmin, would you like to add something to this? Oh, perfect. Then in that case, what I can simply do is
Hello?
continue. Yeah, we can hear you, Ilias. We can hear you just fine. Thank you for your answer. So
I think I have a bad connection.
no worries. That's totally fine. I think Ilias covered the question pretty well. So in my case, what I'm gonna do is just continue the rest of the at least 2 or 3 questions next. So there's this question I think that comes from Noordin Belhaj Sheikh. So let me just share one of the questions. Noordin Belhaj Sheikh, he said, "What is your approach to extend the model to detect new classes in our object? Is it possible to tell us how long does the model take to train, and do you train on the cloud, or is the model adversarial attack proof?" I think this question is also for, I believe it is.
Yeah. Like if we just have a new class, like if they invent a new construction equipment, and like there is one object that we didn't cover in our data, so we just add data and retrain the model again. That's not a big problem for us, like to retrain the model again with one class, and that's it. How long does it take to train? It depends. It depends on like how big is the model, how is the input size, like the architecture. I can give you an example. We have 2 models actually. We have like a model for it's like we call the big model, which is like for all the construction equipment, and it's intended for high resolution. The input is 1920 by 1080, and it takes like 3 days. This is like a big network. And there is also, we have for trucks where we deploy at the edge, or what, like we want to make small applications for truck detection. We use YOLO. We had been using YOLO VT, and then we use VOLO V4, and it takes around 2 days. It depends also on the size of the data set. So yeah, and the model is adversarial attack proof. No, it is not, and we didn't have this problem before, and I don't think we will have this problem in the future. But if that happens, we'll just have to think about how to solve it.
Thank you so much, Ilias. Let me remove the current question to jump to another one. That will be hopefully more targeted. Yeah, thank you, Yasmin. So this question comes from our previous presenters. So Abdunnoor, I hope you're doing well. So this question is for Ahmed. Ahmed, he said, "Thanks for the great presentation. I assume that many images are needed to train DNN for segmentation. The question is, how the ground truth can be obtained when having large data sets? Can we avoid manual labeling? If not, how many labelers are needed? Thank you, Ahmed."
Very good question, Noor, and very, very straight to the point. I think, especially practically, from the practical point of view, it's a very, very good question. So, my personal approach to this kind of problem is that you usually have let's say a core data set, even whether it's public. Usually starting from public data set and starting to improve it. For segmentation, or for this high detail segmentation, Something that would be interesting is usually to have a green background or green background. So formatting, especially formatting, you have a green background, and you buy a bunch of wigs with weird shapes of hairs to give you a lot more variance in the hair shapes. And once you have this difference, so you don't have to label each pixel individually. Just trying to threshold them by colors will give you a lot of actually ground truths with that. So this would from one thing. The other thing is that once you have those green screens, you can do a lot of data augmentation. So you just do replace that green screen with any images you want, and you do your data augmentation with noise, rotation, background, contrast. You're going to be expanding your space, and this will be without a lot of manual labeling inferred. So there's definitely always needs to be at least for big scale operation, you're gonna have to at least have 500 to 1,000 images that are actually correctly labeled. From that one, how many labelers are needed? It really depends. You can outsource it. Here in Japan, there's a couple of companies who do it. There's companies in India. So if you're outsourcing this one, it's gonna depend on how good they are, how good is their labeling tool. But yeah, I think it's gonna depend on a lot on the augmentation. And as I told you, the green screen technique, I think it works. It works quite well for data augmentation to get a high quality.
So I would like to follow up on this question. Maybe I don't know if I have the right to ask a question, but on the same tone. So don't you think that by doing this, you are going to lose one of the cues, which is like the depth of focus, or like, for example, the fact that you have a sharper contrast or edges when you have close distance compared to the background.
That's a very good point. That's a very good point. It's just that for this kind of application, for segmentation, you actually need to be able to handle both. Whether it's a very crisp background, and actually that's the one that's more difficult, because frequency wise, background and foreground will be exactly the same, so that will be harder to do. And you actually, basically, when you have that green screen, you're gonna have, if you want to replace it and you want to augment that kind of data, you basically can control what kind of frequency you're going to be adding in the background, whether you add blurry backgrounds or sharper ones, or even color-wise similar to the foreground, so that you can really mess with your model.
So you try to simulate somehow the blur in the background, and that's great. That's great actually, because I believe that that will give you also an opportunity to simulate like different type of phones, different cameras with different focus. Perfect.
Thank you so much, guys. Thank you. Thank you, Abdul Noor, for this question. We'll jump to another one that is also for Ahmed, since you are answering. So it's again from our friend Nordin. I would like to thank Nordin. He asked a lot of questions, and also Fuad Bous. I'll try to go through your question as much as possible. If I skip one, it means that I just want to prioritize people who didn't ask a lot of questions. So Nordin Bidhaj says, Ahmed, one of the main problems with deep learning is computational resources. So how does AI amateur that uses deep learning models overcome this problem?
Okay, very, very good, very valid point, and I think I mentioned it earlier in the presentation. You definitely don't have to start by training a 2 million image network. You can, if you're really an AI amateur, you want to start. Are you able to run already trained models? Are you able to download ready models and run them first on Windows? Usually, you can do this on almost any machine. Even if I'm not sure, there's probably a lot of models that are built specifically for CUDA for NVIDIA GPUs, but usually you can do it. Even if you have a simple GPU, the inference part you can do it quite easily. Second part, if you have limited resources in trying to, if you have limited resources when training, it's understandable. You can first try to train smaller size images, smaller networks, or I actually know there's my younger brother who's in Algeria and who had this kind of issues. There's actually a lot of resources. If you ask, I think Amazon offers a lot of credits for students. Even I think Microsoft might offer some computational resources for students, like cloud-based computing credits or something like that. So there's a lot of resources. If you're able to go out there, send an email, just Google a little bit. How can I get some resources as a student? I think you actually can find a lot more than you think. I hope I answered the question.
Yeah, I think you answered perfectly. Thank you so much. I would like to simply add maybe to Nordin, there's an interesting tool called Google Colab. I don't know if you've mentioned it, Ahmed. I know
No.
that they offer a lot of resources on the background. So you just send your algorithm to their Google servers and they do that for you. So take a look at it. I think it should be interesting for you. So I will give the hand to Yasmin for the rest of the questions. So you can go ahead, Yasmin. Oh, I think you are muted, Yasmin. Oh, yeah, you're muted.
So I have another question from Nordin Al-Hajj for Ahmed or Ilias. So why working on a deep learning model? What are your decisions on the model architecture, like layers, loss of function, optimizer, learning rate, as none? So who wanted to answer to this question?
I can take it from my side, and we can answer it both. Yeah, I think trying to find the best loss function or the optimizer, you basically cannot guess, obviously. So if you have a problem, usually there are some similar problems in the academia. So you can get some papers, you can get some hints. My advice is that if you have a problem, you should never start from scratch trying to build that perfect network. Try to find the nearest problem already solved out there. Try to use that model or try to reproduce that model on your side. Once you're able to do that, while you're doing it, you'll actually be able to understand a lot of the issues that are going on with the problem, whether it's the loss function or the learning rate, or depending on your data or the architecture. So once you're able to do this, actually the process is gonna bring itself. So if you see that your loss is never going down, you're probably need to improve to increase your learning rate, or there's a problem with your the definition of your loss function. As I mentioned earlier in my presentation, if you do the training on human segmentation without the specific edge loss, you're actually gonna have a loss that will go down really quickly, and that's almost gonna go to zero. But if you see the results themselves, they're not be very satisfying. So there's a lot of these tuning parameters in the model, but you need to get the core and the definition of what your error means, what your loss physically or basically pixel wise means before you start learning. So there's a lot of homework before you actually start doing the learning, and once you do your homework right, I think the details from the optimizer and learning rate are gonna follow in a very logical manner.
Ilias, do you want to add?
Yeah, sure.
Okay.
I think it depends on what's your job. If you are a researcher, scientist, or you are applying AI in the industry, I think if you are applying this, you don't really have time for experimenting with a lot of things. What you can do is read research papers and use research from people, like use results from people that are already doing research. And like if you're lucky, I think that's like most of our problems like have already been solved in the research, or there are techniques that we can start with, and like you can find all this information in research. And otherwise, like if like you want to train your model also, like I think there is no, sometimes, for example, for the optimizer or the learning rate, there is no like good answer. You just have to try different optimizer, different learning rate, and see what works both like best for your case. It depends. Like I think it depends also like tightly with on the data set.
I just want to add something here, and when we bring the same problems to the context of edge, we may have added issues to deal with, which is maybe some of them can be taken as kind of post-training, and some of them that they will require some retraining, and those maybe not for beginners, but for advanced users who want to be optimal on the edge. Maybe Ahmed has already experienced this type of applications, like for example, pruning, because when although as Ahmed said and Ilias said, you don't need to start from scratch, you don't need to reinvent the wheel. It's better to start from something which has been proven in the same domain and try to personalize it. So personalize it from training point of view is to maybe sometimes train it, but sometimes you do tuning, like for example, to remove the extra complexity that is not needed, because it would be on CPU or PCs and the data centers and so on, you may not have this resource constraint. But on the edge, it's important that you remove any extra complexity, any extra dimension that is not adding value to the model. So that's why you have different levels of maybe post-processing stages, like pruning. You can have cross pruning, depending on your target platforms, what are the features that you have there. You may end up doing maybe more fine-grained prunings or some quantizations or some kind of mixed precision techniques, depending on how hardware can be used. So there are a lot of, in addition to the basic questions that were asked here, there will be some more advanced techniques that are bringing to the picture with this advanced features that are brought up by the big producer. Like for example, if you take an example is NVIDIA, who introduced their Ampere technology, which features the sparsity, and the way they introduce sparsity is what they called it's what they called fine-grained structured, which is the new thing they come up with, which is something between structured block sparsity and fine-grained sparsity. So when you understand the concept and you find that actually they in order for you to leverage that feature, you need to impose every for adjacent weight in your weight set used, you need to switch them, both of them, to 0. Then you need to come up, and they have their own way of retraining, constrained retraining, to oppose that. Now, those are advanced features that if you want to leverage this feature in NVIDIA, you have to go those steps. Do you need to do them as a beginner or as first step? Definitely not. So you go gradually to that level. Yeah, so I'm sorry, maybe I took you a little bit further, but yeah, I think when you come to the edge, you may have a lot of opportunities to go even further than when you are in the cloud or data center. Maybe Ahmed, I don't know if you agree with me on this.
Yeah, no, definitely. I think you covered the basis. Yeah.
So thank you for your answer. We're going to jump to this question from Fuad Bou. So for Ahmed, are you applying any minor image compression to speed up the semantic segmentation?
Very good point. Very good point. Actually, so I'm not sure what you call minor image compression, but yeah, usually this segmentation is usually done as I mentioned in the presentation. Maybe I can show it. Not sure. Can I share my screen?
You should be able to.
Yeah, I'm sharing my screen. Is it? Can you see it right now? Can you see my?
Yeah,
Can you see the size?
We're at the construction equipment
side. Let me just go over here. So here, when I was showing the process that we go through here. So once you do your face detection, you just basically try to get the it's covered by the question. Yeah? So once we do our face detection, we basically crop the area that we need, and most of the time we actually compress the image before doing the segmentation, because The network we usually build is for specific size. So if it's 800 cross 600 pixels, so we're gonna have to basically downsize the image. So I'm not sure if that's what you're calling compression. So we downsize the image before we run it through segmentation, and then we upscale and do some filtering to get it right on the image, so that to avoid the rescaling artifacts. If you're talking about some different kind of compression, I'm not sure how would that.
All right.
But I think, Ahmed, if I'm not mistaken,
Yeah.
so what you are, because this is the type, and you are talking about segmentation. It's a kind of binary segmentation, isn't it?
Almost.
Yeah.
Actually, the best case scenario is an alpha. It's an alpha map, so that we get transparency basically. Because for each pixel.
No, but what I mean is that you are not going. Your purpose later is to mask what is foreground, what is background.
Yeah.
But I mean, from the original image, you are not going to capture all the details, which means that if you cannot reproduce the image through your network, so you are maybe this. So you cannot say, okay, I have encoder decoder, so I can stop at the encoder, and then I save this image instead of saving the original image. This is not true, because your purpose is not to regenerate the image, but regenerate a mask.
No.
So it is not enough to generate the encoded image. We can use it as a compression technique. That's maybe the way to say.
Okay. I think that's what.
I think I don't know if that's what you mean.
All right. So no. Our goal is to get an image the same size as we gave in the input. So no, we're not taking anything from the.
We are more or less masking the original image somehow.
Yeah.
Okay.
Basically. Yeah.
Okay.
Thanks.
Perfect. We have same question, like same context of question from Nordin Belhaj, who said, have you considered the idea using an autoencoder to compress image and store only the extracting features on the phone instead of JPEG, PNG, classical compression techniques?
That's a very good point. Actually, the image format industry is booming right now. There's a lot of information that needs to be saved. Obviously, the JPEG and PNG bitmap formats have been around for years now. They are proven to be. I mean, we can make their codecs quite easily. They have been ported to a lot of hardware. But yeah, there's a lot of information we want to save along. So first of all, there's a lot of information we want to save along with the images. Let's say, are there faces? Where was it taken? So for example, now we have the ability to get the location of the images. But let's say how many faces it has. If we have any semantic information in that image, if we have depth information of that image, can we save it along with it? Apple does something similar. We have something also, but it's still very, very platform specific. Now, if you talk about the automated compress the images and store only the extracted features on the phone, so this, if it makes sense in a computational way, yes. But if we're talking just purely images here, and you have the JPEG, which is really compressed already, and on the other side you have this autoencoder, the autoencoder output, which is basically encoded. So in order to read it, you're gonna have to decode it. So will there be a big difference in the image sizes between the JPEG one and the other one? Will there be a big quality difference? So all these things need to be considered before actually changing all of this framework of how to manage memory. Because to be honest, now memory is cheap. So memory on the phones is getting really cheap, and with all the cloud services, you don't really need to save a lot of stuff on your phone anymore. So size as in static physical memory is not that expensive anymore. So now what we are looking for is how to save higher quality images, not JPEG. So can we get lossless compression to a better level? This is still a research subject, even if it's not lossless, basically visually, let's say visually lossless. So there's some techniques, some saliency techniques that try to find the most meaningful parts of the image and give them more bitrate, and let's say less meaningful parts of the image, give them less bits, and encode them in a way that the image would look really good at a fraction of the size. So these kind of compression techniques, specifically compression techniques, are still a research subject, and a lot of people are working on them. So yeah, it's on the phone, the memory is still cheap. In data centers, of course, it's a lot more expensive. So it's a very complex subject. Sorry, I went on a tangent here, but yeah, it's definitely compression is a subject, but you're gonna have to ask the question of why would I do it? Am I looking for less memory? Am I looking for better quality? So your answer.
But you can also use you may need it also for bandwidth, yeah. So
yeah, if you're transferring it, yeah. That's
so.
Thank you, Ahmed. So I have another question from Ahmed Boudissa, who said, what is the best way to introduce artificial intelligence into the Algerian market, according to our presenter, considering the lack of software, copyright law, and infrastructure that is not yet as ready for artificial intelligence as its developed countries?
Maybe Ilias or Sofiane, you can take this one.
Sorry, sir. Yes, you want to take it?
You can start. I have some comments.
What is the best way to introduce AI into Algerian market according to our presenters? I think the best way is to follow our competition and contribute, try it, and yeah, considering the lack of software. I think what there is a very good answer, which is open sourcing. I mean, I don't think there is okay. There are two things. So there are a lot to start with, like what we were Ahmed and Ilias were saying, is that you may not start from scratch. You can use trained models, and for development you have open sources. You go to Intel, you find they have OpenVINO, and with a huge database of networks, trained networks. There are a lot of free data sets that are free to use. There's nothing to worry about. Now the issue is when you start personalizing things. When you start, for example, trying to train your when you start training your models locally, we don't have a. I mean, regulation is not following this in our country. We know about that. So you cannot go to the street and start, recording data for your training and so on. Definitely, I think when you reach that level, you'll be in trouble. But until then, to get the skills to build proof of concept and so on, I think you have everything. From software point of view, you have all the tools, the frameworks that are free to use, data sets to start with, existing topologies. And courses and everything. Yeah. So I think until you reach. Yeah. Go ahead.
I think maybe what Mahidin is trying to get to here is the commercial side of things. Is that in Algeria, since there's not a lot of software copyright laws, so if you release a software to one client, there's nothing that's keeping them from making 100 copies out of it and using it without that. So yeah, that's definitely a problem. That's a regulation problem. So you're gonna have to go to make some sort of dongles, some licensed dongles or something like that, so that they're being used on a single machine.
But I think. Yeah, go ahead, Ahmed.
So just the second part is about the infrastructure. So what we're talking about here is the edge AI. So For the edge AI, if you have your edge device, you should be able to do it. You don't need a lot of bandwidth, or you don't need very high-speed internet to be able to do it. But I think in Algeria, with the lack of high-speed internet and coverage, definitely edge AI has its value here. If we're doing it on the edge, it's much more interesting in Algeria, I believe.
I think a part of it also, when it comes to infrastructure, is the first question about training and so on, and maybe what your first answer that one, which is the cloud, and maybe what depending if you are a student, there will be some maybe stuff that you can use. I think. But in terms of copyright, so the next webinar, just for your information, that we will have very interesting experts that are going to give us a presentation about intellectual property and all the related stuff. I think he will be much better than anyone else here to guide you through that. But we all know that it's hard to protect yourself if you are developing software in the country. But look, I think when you reach this world, you don't. I mean, Algeria would be just a small part of the world, and you will be protected elsewhere. So doesn't mean that you shouldn't do it just because of this reason. Because if you develop something which is interesting, you can sell it outside, and then, but in all cases, you need to have the right protection and so on.
I can add something to that. First thing, I think one drawback of not Algeria having good software infrastructure is that I think we didn't generate any data, unlike other countries. We don't have. I don't think we have because we are late in digitalization. We don't have data needed. I don't want to be pessimistic, but we are late compared to other countries in having data that can be used in AI for example, problems. That's the first thing. The second thing, copyright laws and software. I can give you an example. Evercam, for 2 years, their software was open source and was accessible to anyone. They can just clone it and deploy it and to work. But not I don't think this is the reason, but it was written in the backend was written in a very new language and weird, which is Elixir, Phoenix, and the backend. But I don't think. I think if you are making something big and you are moving very fast, and I don't think you have to worry about these things. And also now most of the software is software as a service on the cloud, and the client doesn't have any access to your code, and you just pay for the service that you are providing. Also, I think on the edge, when you have your programs also already compiled and everything, I don't think you risk anything. I'm not worried about that side. That's it.
So thank you for your answer. We have another technical question from Fouad Bous to Ilias. What's the size of your dataset? How big your CNN model, and what's the average flops required to run one feed forward for inference?
Yeah, sorry. So the size of the dataset is 200,000 images. We have when I say images, it's containing, as you can imagine, construction sites containing at least 10 objects per image. And the CNN models we use, for example, sorry, we use ResNet 101 for equipment for the big model, which is for any object on the construction site, and we just use YOLO for the truck detection. What's the average flops required to run one feed forward? Depends on the architecture and input size. For example, YOLO for YOLO v4 that we use, it's 150 B flops with an input of 672 by 672.
Perfect. We will take the last question from Laid Bunabura. So he said, how can we find better way to apply this tool and process in the civil engineering design process? Who can answer this question?
I think for civil engineering, it's definitely Ilias. It's closer to Ilias.
Yeah. So how can we find basically ways to apply these tools? Okay, when you mean these tools like deep learning and AI, civil engineering design process, civil engineering design process.
So what does it?
I don't have an idea in my head right now.
It's very hard to discuss. It's very general question. So I think it depends on what do you want. What is this about? I mean, like I don't know if the purpose here to, for example, to check the resistance of materials and so on, then it's different than if you are designing a bridge. So I don't know what we try to model, but I think that AI can apply everywhere. So
Yeah, I think for civil engineering, even now there's a lot of classical optimization methods to find the optimal amount of cement to steel to use for certain resistance or for certain characteristics. If you have this kind of classical models, optimization based methods, definitely you can be able to solve this kind of. It will probably be some sort of regression rather than what we're doing here for computer vision, but it will be more of regression problem solving. Maybe you can explore this kind of direction later.
I think there is also another thing is
AR applied to.
Yeah. Okay. I think I was going to say sometimes we start with a problem rather than start with the solution, and that's maybe what is missing here. So yeah, we have the tool, but we have to know what's the problem to understand what tool you need to use.
Yeah, I think so, and I think this is a very important point, Sofiane, because like I think like a lot of, and also Ahmed like mentioned this, like AI is a hype, and everyone is excited, and I think like everyone should be excited, but I don't think. My thinking is it's not the starting point. The starting point is the problem. You start with the problem,
Exactly.
and yeah, that's just a tool that can like.
No, I think yeah, there's no more stupid than training a model to learn a linear movement. Yeah, so anything that you can model without AI, I mean, you shouldn't use AI. You must not use it. You know, you have to use it exactly only if you need it. And yeah.
Perfect. I think we finished with the question. We'll let Hossein to finish the webinar.
All right, thank you, Yasmin. Thank you, everyone who asked the questions on the Facebook Live. I would like to apologize first for all the ones that we unfortunately couldn't take their questions. What's gonna happen is that all the people that were involved in this presentation are probably gonna go back through it and maybe answer some of your questions. If you had any suggestions, also we are going to do the same thing. We're not going to skip them or just avoid them. So our goal is just to get as more question as possible and also diversify from one person to another and give everybody's chance. So thank you everyone for answering the question. I would like to start thanking Sofiane for being available today. So thank you so much, Sofiane, for your help. It was really appreciated. Yeah. Thank you also to Ahmed. I don't know what to say exactly to Ahmed.
Exactly.
Is it Ohio gozaimasu right now? Or
It's 6 a.m. already.
That's it.
It's time to wake up.
It's 6 a.m. I got it. I got
Exactly,
the right call. So maybe soon in the next webinar we can explain how translation is done. So I was able to do this quickly. I know nothing about Japanese. So thank you so much, Ahmed. It was
Thank you very much
to
for
have.
organizing. Have a good day.
Of course. Ilias Dahi, shukran jazilan. Merci beaucoup, Ilias, for this presentation. We really enjoyed what you've said, and also we invite both of you, Ahmed and Ilias, to take a look at the comments if maybe so you can answer some of them. So thank you so much, Ilias.
Yeah, thanks. Thanks. That was my pleasure, Hussein. Thank you.
Thank you, Atik Saha. And finally, thank you so much, Yasmin, for being available. It was really helpful.
My pleasure.
Thank you. All right. Before leaving, thanks to all the organizers and also the
Can I just thank you Hussein and Yasmin for coordinating this. Thank you. Great job.
Thank you.
Thank you so much.
Thank you.
Thank you to INAC. Thank you to School of AI. Thank you also to the Open Minds group. We really want to thank
Hussein, can I ask you something? I mean, there is a guy who was suggesting something, and we didn't take his suggestion, and he was maybe a little bit upset. He said, "Thank you for not taking my suggestion." So we just apologize for him and for anyone who we didn't answer a question or take a suggestion. So thank you.
Exactly. We'll do more effort, hopefully, inshallah, next time. Thank you so much, guys. And I'm not going to take too much of your time. I really thank you for everyone who attended this webinar, and we'll see you guys soon, inshallah, in the next webinar. Thank you so much.
Thank you.
Thank you.
Bye.
Thank you very much, Hussein. Thanks, everyone. See you. Bye.
Thank you.